Today's topic is solar distortion. I'm Jim Brewer for Rooftop Safety, and real excited. Today we have Dave Johnston with us. He probably understands more about solar distortion than anybody. He was worked for the Vinyl Siding Institute, retired recently there as vice president of technical. So he's really studied this thing. But Dave also has a long and impressive record in the chimney and hearth industry. He's a past NCSG instructor and board member, chair of the NCSG technical committee. He was the principal author of the CSIA white paper, Chimney Fire Causes, Effects, and Evaluation, major contributor to the NFPA levels of inspection standard, former NFPA 211 committee member and chairman. I've known Dave a long time. Him and I we were actually the first instructors for what's now CSIA. Originally at the time it was the National Chimney Sweep Guild, but in 1986 Dave and I were traveling all around the country doing weekend 2-day seminars for the chimney sweep certification program. So fun times. In a few years ago. Wow, 1986.
I was going to say, that was 1986.
That's when it was, yeah. 1986,
wow.
34 years ago we were teaching. So anyway, I'm looking forward to this today. So what is solar distortion? Okay. It's basically distortion of vinyl siding, but it's not totally vinyl siding. It can happen to plastic car parts. In my house, it was actually burning the grass a little bit. Didn't set it on fire, but browned it out severely. But the distortion occurs when the sun rays are reflected and concentrated off of a reflecting surface onto the siding. The reflecting surface is generally low emissivity, low E windows. And the concentration occurs because the window pane flexes or bows. So it concentrates it. If you were ever in the Boy Scouts and started a fire with a magnifying glass, just concentrating the sun's rays onto some little dried leaves or pine straw, you can get it to ignite. Fortunately, the vinyl siding isn't igniting, but it is getting distorted and doesn't look good. So this shows a typical low E windows. All the ones I'm familiar with seem to have a gray tint to them. And consumers love them. They really reflect heat off of the window, so less heat is absorbed into the house. They're more energy efficient. The builders love them because it helps them with their overall energy ratings that they have to achieve for the homes. So they're becoming fairly common in the marketplace.
Jim, does low E mean low energy, or what does the E stand for?
No, the low is emissivity. Basically,
go back to your previous slide, Jim.
Okay.
That second bullet.
Okay.
Emissivity. And basically what that means is that it reflects a greater percentage of the light in the infrared part of the spectrum. So, and unfortunately that diagram shows UV light reflected, and that's true, but the real point is that the infrared part of the spectrum from the sun is more a greater percentage of that is reflected than with just plain old glass.
So this is not a normal glass as we would know glass.
It's just glass that's been coated with it's kind of a metallic particle coating that creates that effect.
Cool.
And that explains the gray tint that Jim was talking about. Is just a very semi-transparent metal. It's like spattering.
Got it. Thank you.
So that's the classic look, the gray tint to them. And in this picture, you can actually see the sun reflecting off of that with that kind of characteristic X pattern. So what happens? Okay, the concentrated and reflective energy can create surface temperatures up to 250 degrees on the siding, which is enough to distort it, as you see in this picture. However, the ignition temperature of siding is over 700 degrees, and there aren't any reports of fire from this, so the likelihood that you're going to burn something down is very, very, very slim.
Jim, could this affect pyrolysis of framing members underneath it after 20 to 30 years?
Oh, that's an interesting question.
I mean, we've got fasteners going in, we've got framing members. I'm presuming most siding has framing directly against the siding. So you're making me wonder about pyrolysis right now, 20 years down the road.
Well,
Go ahead, Jim.
My first thought there is the time, and Dave will probably talk a little bit more about this, but the time that this actually is able to happen is slim. It's all about the time of year, the sun's angle in the sky, and things like that. The position of the target surface versus the reflective surface. I don't think there's enough time exposure where you're going to cause significant paralysis. That's my gut feeling.
We did take a look at that, and first of all, with respect to the wood underneath the siding, the siding intercepts the heat and absorbs the heat, so that the wood underneath it isn't going to get that hot as long as the siding is there. But it does raise the question about, well, what about if it's a wood-sided house or a T111, or some form of wood material that is hitting it? And the likely answer, I'd say that we don't know for sure. The likely answer is that for normal-sized windows under normal circumstances, it's probably not going to get to the point of ignition, even accounting for pyrolysis. And part of the reason is because it's out in the air, so that the heat can dissipate. You can get a brief temperature rise while the light's right on the wood, but then the heat can readily dissipate, as opposed to like a framing that's inside or right next to a chimney where you don't have air circulating around it and the heat can't dissipate as readily. Now, and having said that, early on in this whole experience, in fact, one of the first incidents that came to light actually did involve ignition of wood from reflection from very large skylights and I don't know the exact orientation and how the reflection happened, but these were big skylights with a lot of area, and they became concave in shape, and the reflection apparently reflected up onto the side of the house that was above this like porch roof that the skylights were mounted into, and there was ignition there, and it happened several times to the point where the Consumer Product Safety Commission actually required that those skylights be recalled. And that's one of the first things that led to scrutiny of this whole phenomenon, actually, before final sighting became the poster child for what was going on. But I think the general feeling is that it's not real likely to get hot enough or persistent enough to actually ignite even wood, but it's not outside the realm of possibility.
Cool. Thank you, Dave. So here's some more views of it. And you can see in the picture on the left with the single window, kind of an angular pattern going up the wall. And that angular or arced pattern is related to the sun's travel through the sky. In the picture on the right, you can, with the multiple windows, you can see where there's multiple reflections, probably coming off of the adjacent building next door. And you can see where it's affected the siding in several places on the building. So it's, you know, it's common, and it happens. So why do chimney guys care about it? So my first exposure to solar distortion happened when I was called to inspect a chimney that looked just like this. It was a vinyl-sided chase that stuck out from the building at a right angle to the low E window, and it had distorted the siding on the chase, on the side of the chase. And so the consumer, you know, was concerned that there was a fireplace problem, because it, you know, the siding on the side of his fireplace chase was melting, and he just assumed naturally that it was a fireplace problem. And so got to looking at it and studying it, and that's when I came across this whole thing about solar distortion. But over the years, we've probably been called about this exact thing 25 to 50 times. I don't know the exact number, but it happens. I've heard stories of, you know, chimney guys, you know, opening up the chase to investigate what's going on inside of there. But think about it, and this is what really struck me, is how could we get enough heat from a fireplace, you know, all the way to the outside? It would first have to go through the insulation, past the framing members, past whatever sheathing is under the siding, maybe a vapor barrier over the sheathing, and then ultimately to the siding. And I was like, how are we going to get that much heat from the fireplace without burning something down? It just didn't make sense to me. But it's common, and chimney guys get called about this often, and so that's why I thought it would be an interesting topic to talk about. So these are some pictures I took, and the picture on the right was like the second case I investigated, and it really became clear to me when you could see the reflected sunlight on the side of the chase. That was, you know, incriminating evidence, so to speak. But again, this is another fireplace chase, and the sun strikes that window at a low angle, a grazing angle, and reflects it onto the chase. And this is most common in the winter when the sun is lower in the sky. When the sun is, you know, down hanging over the Tropic of Capricorn in the southern hemisphere, in producing low angles back here in the U.S.
Now that's an interesting thing there that you just said. I never thought about.
What's
So you're
that,
saying
Jerry?
this about it being more prone in the wintertime than the summertime because of the sun angles.
Yeah. This whole thing is all about, you know, the angles of the windows, the angles of the sun, the angle of the distorted surface in relation to the window. Hopefully we'll get Dave to talk more about that.
Yeah,
So,
the other factor there too is that there's a greater temperature difference when the air is cooler and the siding is cooler. There's a greater temperature difference between the parts of the siding being heated by the reflection and the parts that are still cool. And it's really that large disparity in temperature that leads to the distortion.
So colder the siding is, the more likely this is to happen, Dave.
Yeah, I mean, it'll happen in the summertime, don't get me wrong, because it doesn't, you know, it can get so hot that there can be a lot of temperature difference even if the air temperature is warm. But there's, you know, there's a little bit more possibility of it when the air temperature is cold, because there's a potentially greater temperature difference between the hot parts of the siding and the cold parts.
Interesting.
so this picture here is actually in my neighborhood. I saw this picture a couple of weeks ago on my morning walk, and that's when I said, "Hey, I had to do something about solar distortion," and I took this picture. And when the reflecting surface or the window is on another building, it seems to cause this type of issue more when that window is facing south or close to south. So the picture on the right was taken from Google Maps, and it shows the orientation of this building. The lower building in the picture is the target that you see, the large siding that's distorted, and then the upper house is where the window that's causing the problem is. And I put the north arrow in there. So that window is predominantly facing south, and that's when this is more likely to occur, when there's the southern exposure there. So what to do? You know, customers, once you let them know that it's not their fireplace causing the problem, then they're like, well, what do I do? And you know, window coverings, blocking techniques like fencing or plants and trees to stop the reflected energy from reaching the siding. You know, and let them know, ease their concerns that it's not caused by the fireplace once you've, you know, reasonably ruled out fireplace causes. But again, I can't really imagine any scenario where the heat from the fireplace could distort or melt the exterior siding without first causing a problem on the inside. So anyway, actually that's not the end. Dave's going to show us some video. I'm going to stop my screen share and let Dave share some video that he's going to show us. So go ahead, Dave, and take it away.
Okay, let's see, where do I want to be? Ah, here we go. First, I'll show a video, but I want to set that up a little bit first. I was called to a development in Northern Virginia, in my area, and it was a convenient and good timing for an opportunity to investigate an actual case of what was going on. And here's the situation: is the house on the left had extensive damage to the siding, and I'll show pictures of that in a second. And the house on the right, particularly the upper three windows, there you see on the right side of the upper right side of that house, were clearly the source of the reflection. Now this is an interesting case in that this house was facing west. The house on the right was facing west, but so it was a late afternoon phenomenon, as we'll see. This picture, by the way, was taken around 1 o'clock, and you can see the reflection from those three windows is striking the side of the side of the same house, the side of that projection there. So you can see the three reflections. Excuse me. Another view of that house. This is the house that's the target or the victim. And this picture doesn't show it particularly well, but you can see that pretty much that entire wall has been distorted to one extent or another, and it's greater in some parts of the wall than others. This face of the house got a lot worse damage. You can see particularly up there between the two sets of windows, it is really badly rippled.
Wow.
Dave, has there been any cases of litigation over this yet?
Yeah. I'm not aware of what the outcomes or how they've been resolved, but I know that there are cases where people have sued their builder over the in some cases, alleging that the siding was defective, which of course it wasn't, and that's an easy one to dismiss. In other cases, alleging that the window was defective, which really isn't true either. The windows weren't defective; they're designed to do what they do, and I'll get into that in a second. Now, whether they should be designed to do that is another question, but you can't blame the builder for installing a window or for that matter, the window manufacturer. You can't blame them for having, you can't say that the window is defective when it's doing what it was designed to do, and now they may need to reevaluate the design, but that's...
Has anyone sued their neighbor?
I'm sure that there have, and I know that there have been cases where people have taken their neighbor to task, and I'm sure there have been some suits resulting from that. But I'm not aware of what the outcome of those has been. So I don't know how that plays out. When I think we'll want to go back to one of the slides Jim had that talks a little bit about the solutions, because there are solutions. It's just a matter of the neighbors need to cooperate in order to implement those solutions jointly, because it really does usually take some cooperation. Anyhow, so there's another idea of how badly distorted that was and how widespread it was. Now, what's interesting is that this is a pretty extensive problem in this neighborhood. You can see that even at this time of day, where it's around 1 o'clock, and so the sun that is a west-facing window, and so the sun, as the sun passes from the south toward the southwest, the reflection from those windows hits that wall as the sun is passing along, and even the reflection coming off at that angle from those windows is distorting the siding on the house that that's the cause of the distortion on the other house. And not only that, but this is the house that's the target of the neighbor, but it also is causing distortion to itself. The victim, so to speak, also had the same kind of windows, and those windows themselves at when the time of day was right, and when I took this picture, the time of day wasn't right, so you can't see the reflection, but you can see the distortion. coming off of those windows, the reflection hits that side of the house there at a 90-degree angle, just like the fireplace chase that Jim was talking about. So because this neighborhood had windows that were very prone to the distortion problem, to the it's called collapse problem, there was extensive damage pretty much everywhere you looked. Now, what goes on here, these are low E windows, which means they reflect a greater percentage of the solar energy that hits them. And that does mean that more energy is being directed at wherever the reflection hits. But if the glass were flat, that reflection would be a big wide area. It would be the same size and shape as the window. It would not be a concentrated spot like Jim showed in some of the pictures earlier. What happens though is that these are double pane, or in some cases triple pane windows, and as the pressure inside the window between the two panes reduces, the glass is actually pulled inward on both sides, both the interior and the exterior, so the glass becomes bowed like a concave mirror, like a concave mirror you might have in a bathroom, for instance, and that creates a crude lens and reflective lens, and that's what causes the sunlight that hits the window to be concentrated into a smaller area. And with more energy concentrated in a smaller area, obviously there's more. That's going to create more heat and a higher temperature on whatever strikes it. As Jim mentioned, it's not just vinyl. Vinyl siding on your neighbor's house is a big target, so that's why it tends to be the poster child for this phenomenon. And because it's plastic, it does distort relatively easily compared to some other materials. But as I've mentioned before, other materials can be damaged. Wood, grass. So some people have actually been burned by like sitting out on the deck and having the reflection pass over them. That actually happened. Became a big national story at a hotel in Las Vegas where that happened. At any rate, the key point is that the window becomes concave, and the reflection from the window thus becomes concentrated. So it's not the low E so much as it is the reflection that creates the problem.
Hey, Dave.
Yeah.
Well, this picture shows it as well, but go back a picture or two. So you see how the actual reflections that you're seeing in there have a curved appearance to them? Is that because the window is bowed?
Yep.
So that's proof that window is bowing.
Yeah.
Because
if the window weren't collapsed, it would act just like a regular flat mirror, and you would see yourself in it, or whatever, whatever is being reflected would have the same straight lines that you would expect out of a regular mirror.
Okay, cool.
Dave, by
and
chance,
this is like a funhouse mirror.
Yeah.
Dave, you mentioned a while ago double pane versus triple pane. Is one more to have more of a tendency to cause the issue than the other, or is it equal between double and triple pane?
I'm not aware of any difference between the two. The key point is that the gas that is trapped between the panes when it's manufactured, which can be air, or it can also be a gas such as argon, intentionally put there by the manufacturer. That gas can very slowly leak out, and as it leaks out, it doesn't get replaced by air from outside. It just leaks out. So you've got less gas in between the panes, and that causes a lower pressure, and that lower pressure pulls the glass inward.
Okay, so the gas escaping is part of the issue. If it has, the older it gets and the more leak it comes out. So where someone may not have the problem when it's brand new, in 5 years they could have the how long does it take for this leakage to start happening on average windows?
I can't answer that because it depends on the window and manufacturing precision. One of the for the window standard that glass manufacturers use for multiple panes, it does have a requirement for linearity, basically parallel, the glass being parallel at the time that it's manufactured. Even then, it doesn't have to be perfect. There's just a degree of tolerance that's considered acceptable. And then just depending on how well sealed the window is and what conditions it's exposed to, and even the elevation the elevation that it's at, because that changes the exterior pressure. All those things can make a difference. And so it's hard to give any prediction. It definitely doesn't take years. There have been cases in quite new developments where this has happened. This development we're looking at here was probably only 3 or 4 years old.
It looked new,
Yeah.
fairly new.
So one thing I wanted to point out, the picture Jim showed before isn't actually what it would look like if you were to look at it. And by the way, I want to point out right up front, I'm not recommending that you look at it. I'm not even recommending that you take a picture like this. I was taking a chance. This could have, ruined the sensor on my camera. It didn't, fortunately, but I don't recommend you trying it. But this really illustrates the point about the difference that concavity of the window makes. What you're seeing there is the reflection coming from every surface of that upper sash. Every surface. In other words, every light ray that hits the upper corner, the upper right corner, the lower left corner, in the middle, everywhere, is being reflected into a single point, which happens to be my camera lens at this point. That's what it looks like when the window is essentially acting like a huge collector of solar energy that then concentrates it into one spot. So if you look up, and again, I'm not recommending this, but if you see a round reflection of the sun in the window, that's not the problem. The problem is when you look up and see the whole window being a source of light. That's when the window is in a shape that's capable of causing the concentration.
Cool.
So here's the target house, and notice the reflections it's now about 3 o'clock, 3:30, I think. So it's getting toward late afternoon, and this west-facing window on the house on the right is now reflecting still downward because the sun's still high in the sky, so it's reflecting downward, but it's reflecting more toward the neighboring house. And you can see the light from those 3 windows is still quite concentrated, or it is quite concentrated as it hits the ground there. And then as the sun goes lower, now the reflection starts to get higher up and climb up the side of that house. And as you can see, it's still quite concentrated in those 3 different areas. And so that's the point at which I will play the video. I should ask, are you seeing all this okay?
Yeah.
Okay.
Yeah, it's coming through fine.
So this is a time lapse taken over the next several hours until dusk. So you can see the reflections gradually fade out at the top of the house because the sun's going down. And it's also, it actually gets blocked. The house that's the victim actually blocks the other house, but that doesn't happen until, it blocks the sunlight from hitting the other house, but that doesn't happen until it's, getting pretty close to sunset. So this is what happens, and this explains that curved pattern that Jim showed even better in a picture earlier. And you could see to some extent in this, you can see kind of a sweeping pattern to the distortion, because the sun moves in a curved path across the surface, and the sun is in a different position at any given time of the day. The sun is in a different position as the year progresses, as the seasons progress. And so exactly where that reflection hits changes day by day.
Dave, we're not seeing the video. If you started running it, we're not seeing that.
Oh, okay. It says I am screen sharing.
So
Turn the video on, Dave.
well, you may need to change your screen. If the video popped up in a different screen, you're not showing that screen.
So, okay, new share, that's what I should do. So it doesn't automatically share whatever is on your screen. You have to tell it what to share. Got it. Now you should be seeing it, right?
Yep, now we are.
Yeah.
All right. Sorry about that. I am not I am a new Zoom user, so just figuring this out.
There's a lot of them out here, Dave.
So you can see, like I was saying, you can see the sun moving up the side of the house as the sun goes down, as it comes later in the afternoon. This, by the way, was March 1st, so it was kind of the shoulder between the coldest and the warmest parts of the year. But really, it comes down to whatever the geometry is for the particular location that's necessary to create the right reflection to hit the target. So it can happen in a lot of different configurations.
So Dave, talk for a minute about, so like how wide of a period of time do you think that could happen? Once you identified that that's happening, I mean, it doesn't happen every day of the year. Isn't it a much more condensed period that it could actually happen at any given geographic place?
Well, it depends on the geometry. Well, of course, it also depends on the weather too. If it's cloudy, then it doesn't happen, at least not that day. But it depends on the geometry. Some cases there is a large part of the year where the sun angle is just right to hit the house. Now it'll move; it'll hit a different part of the house, as the season progresses. But it can be over a period of weeks or months even, and and it can be more intense at different times of the year. This doesn't show it very well, but the image that you showed early on in your presentation, the one that you just took a few weeks ago, is a perfect example of where there's distortion over a pretty wide area, but it's clearly much more severe at one side or the other, because the angle is more favorable to creating the higher, even a more extreme temperature difference at that particular time of the year.
I wonder if there are certain things behind the vinyl that create certain spots where it distorts more.
We looked into that too, and we couldn't find any evidence where it made any difference. I mean, some vinyl, when you get a bright light like this, vinyl is semi-translucent, so some energy is, transmitting through the vinyl, but most of it isn't. Most of it's being absorbed by the siding, and so it wouldn't matter what's behind it. It's something that is insulated, something that keeps the back of the siding warm would also contribute to it. But honestly, when you've got the whole house behind the siding, you've got sheathing and you've got insulation in the wall, and then you've got the interior wall, and of course the interior of the house is at 70 degrees. There really is no place for the heat to go. You're not going to dissipate heat out the back of the siding, so most of it's going to be absorbed and cause a temperature rise in the part of the siding that's being hit by the sun. and the part that's not being hit by the sun is going to stay whatever temperature it would have been anyhow. And it's that great difference between the hot part, the side of the part of the siding that's getting heated intensely, and the part of the siding that's not getting heated that really results in the distortion. And just to go back to your original question, we did not find any evidence of it that it made any difference what was behind the siding.
Cool.
You notice too that see those reflections on the right side? They're basically big and widespread. For some reason, the window windows that is reflecting on the right is not collapsed. It doesn't have that concave shape, and so it's creating a more normal reflection that's not concentrated, and there's no distortion resulting from that. So really the key issue here is whether the window assumes that concave shape that focuses the light into a concentrated area. A regular reflection, if you had 100% efficient mirror on the side of that house, but it was a flat mirror, you wouldn't have any problems. There would not be any distortion problems. It's really that concentration from the curvature of the glass that is the key, the key element.
Interesting. Cool.
And I don't have a time lapse of it, but just remember that on this house, when the sun is probably late morning, when the sun is hitting those 3 windows on the lower floor that you see right there in the middle,
Mm-hmm.
that's that grazing angle when the sun is nearly parallel to that wall but not quite, and the sun is reflecting off of those concave windows, and the reflection is hitting that little bump out on the right, down there near the electrical outlet that you
Right.
can see there.
You can see it.
That's where there's distortion there, from its own house. It doesn't even take a neighbor. In this case, they were having the problem on their own house, again, because whatever windows were selected for this development, they were particularly prone to that glass collapse.
And that's been my experience. Is it becomes a thing in certain neighborhoods.
Mm-hmm.
And that's because the builder chose a certain window. But
Mm-hmm.
around here, I know the neighborhoods that have the problems.
Mm-hmm. Mm-hmm.
But that also has to do with the thickness of the vinyl too, wouldn't it? I mean, that has to
Not
come
really.
into play.
No, if in the mildest of cases where the sunlight is just barely enough to cause a problem, then yeah, it might make a difference how thick the siding is. But honestly, this is such an overwhelming problem that thicker or thinner siding, it doesn't make any difference. It's the amount of heat concentrated in a particular area is just extreme. And the siding, the thickness of the siding adds a little bit of mechanical strength to it, but this is not really a mechanical problem. When you're talking about the forces of expansion and contraction due to heating, those are very, very strong forces. And a mere couple of microns of siding thickness isn't gonna hold that back. So that's the window industry tended to want to make an issue about it being a matter of the quality of the siding, and that that just isn't true. Any siding, and in fact, as Jim mentioned, other materials besides vinyl and the things that aren't siding at all, are vulnerable to this because it's such an extreme concentration of energy, far more than any material would normally be designed to expect to happen in the field.
You know, Dave, it's really interesting because you're not the only industry that got hit by that. The landscaping industry got hit by it because it's killing grass, and the solar panel industry has also been hit because it's actually been traced to killing birds in flight.
I hadn't heard that one.
Yeah,
Wow.
go look it up. There's a big thing in California with the solar farms where they're actually killing birds in flight, knocking them out of the sky. Like, I mean, it's just like a death ray.
Wow.
Go look at. I'm serious. Why it's pretty widespread. So it's not just vinyl that's suffering this thing. But if you can imagine a big solar farm reflecting enough out that the birds start falling out of the sky.
Yeah, and some of these solar farms are huge that they're putting in.
Dude, let me tell you something. You get out in West Texas, I have never seen nothing like it in West Texas. It's like they grow these windmills like we grow corn in the Midwest.
Yeah, it's there is a very, very large solar farm on the Indianapolis airport property.
Yeah.
That place is surrounded by solar panels.
When you get done with this, look up solar panels and killing birds in flight.
Cool.
Okay.
Guys, I got to make a trip out. So, hey, Dave.
All right. Any other questions?
Nah, this has been very informative, Dave. Like I said, it's something that's out there. Jim, when do you think you got your first call on this? Because I remember when we got our first call on it, it was like 05, 06, 04, somewhere in that range.
Yeah, I don't know for sure, but yeah, it's probably in that time frame, 15 to 20 years ago.
Yeah, same situation. You know, go out. We had a chase, and all of a sudden the sides melt. It's like, holy crap! Is the vent going? Is it leaking heat? Same 9 yards, and you know, it was really crazy. We never thought that you came up with this solar reflective thing, Dave, but it was pretty amazing because I can remember we did open up a chase or two, Dave. I mean, we were one of the companies that opened it up saying there's got to be something wrong in here, never thinking it could be this reflective stuff.
Right. Yeah, there had been reported cases of it before I joined VSI in 2004, but it was right around that time, 2004, 2005, where the issue started really heating up and started getting news stories on it and things like that going on.
That's a good word. Started heating up, Dave.
Yeah, right.
Okay, guys, I appreciate it. I'm going to back out of here. I got to go take a pizza oven down the road. I'll talk to you later.
All right.
Okay.
Appreciate
Good seeing
it.
you,
Hey,
Jerry.
Dave.
Take care.
Right.
Stay in touch, Dave. Good to see you, brother.
Will do.
Take it easy, Jerry.
Any other questions out there before we
No.
wrap it up?
Jim, you might want to go back to your one slide that talked about solutions.
Okay. And I think you've got to stop sharing.
Oh, okay.
And now I can share.
Back when I was with Hearth and Home, we had about that time, 2005, 2006. We got called in on a case with that. They thought it was the chase, and we went out there, and right alongside was a window that was reflecting onto the vinyl.
Yeah, that seems to be really when it started to really become a common occurrence.
So solutions involve, blocking the reflection, either putting shades over the window that's causing the problem, or blocking the reflected rays from getting to the target surface, the siding that's getting affected. And that can be done with, bushes or, some decorative fencing or something like that. That's pretty much it. The neighbors have to work together to try and solve the problem.
Jim, go back a couple slides. You had your slide that showed the reflection on the side of a chase.
There.
Yeah, go back one more. There. No, that's not one. Go back to where this shows the reflection.
That one?
Yeah. Okay. See the picture on the right. I just wanted to point out the upper sash is glass, and that's what's creating that diamond-shaped reflection. Notice that there is no similar reflection coming from the lower sash, and that's because the lower sash has a screen over it. So a screen obviously doesn't block all the light, but it reduces it enough so that it makes the concentrated reflection less significant. It reduces the intensity of it a lot. And I think in many cases where they've been able to convince the neighbor, or in this case where it's their own window, if they can convince them to put a screen on the windows that are causing the problem, that itself can be enough that can solve the problem. Now, obviously, with double hung windows, it's I think it is possible to put a screen on the upper sash, but they're not intended that way, so that still can be hard to do. Yeah. But in any case where a screen could be put over the window, that may very well address the problem.
Or how about some type of non-reflective tint?
I seem to recall some window manufacturers offering or suggesting that they try a plastic film on the outside of the window. I'm less sure about how well that worked, but in theory it ought to, because it basically would absorb some of that energy that would otherwise be reflected. Now, of course, the problem is when you now put something on the window that absorbs energy, that cancels out the desirable effect of the low E. You've essentially made it a non-low E window again. So, but if it's a choice between a little bit of energy efficiency and damaging your neighbor's property, that might be the best solution. But I don't have firsthand knowledge about how well that worked, whether that would have a big enough effect.
Yeah, awnings over the window, can block the sunlight.
Yep.
Various techniques like that. Okay. Any other questions?
I should say there have been some manufacturers have experimented with trying to basically reinflate the window, get some pressure back in there. But to my knowledge, they don't have any regular way to go out in the field and pump up the window so that it's not concave anymore.
And on the pictures you showed, I mean, there are new windows, so it may not last that long anyway.
Yeah, exactly.
Yeah. So yeah, that would get time consuming if we have to go out and inflate all the windows. But hey, maybe that's a service opportunity.
A new industry.
Yeah.
There you go.
Yeah. All right. Well, there aren't any questions. Thank you for attending, and thank you to Dave Johnston. Really appreciate you being here and sharing your wisdom. And it was fun to be able to teach again with you. It's been a lot of years since we did that. So, thanks for coming. So let's see. Next week on Tech Talk, we're going to talk about electrical safety for technicians. And then the following week, PPE, personal protective equipment. So that'll round out May for us. So we're here Tuesday mornings at 7:30 Eastern, and then shortly thereafter it gets reposted to YouTube. So thank you for attending. Have a great week, and we'll see you next time on Tech Talk. Thank you.